Okay, so in objective 3, we're talking about slopes of parallel and perpendicular lines. And in the picture, you've got some power lines, and power lines, often you see some parallel lines, sometimes you see some perpendicular ones in it, and you very frequently see a pair of shoes that someone's thrown up there as well, right? Okay, so let's review the definition, some geometry here for parallel and perpendicular lines. So we know that two lines are parallel when they are on the same plane and they never intersect each other. Okay, so remember in geometry you usually put little arrows on them to indicate that they are indeed parallel to each other. Okay, for the definition of perpendicular, two lines are going to be perpendicular if they cross each other, they intersect at a perfect right angle, 90 degrees. Okay, and then of course we indicate that with a little red box in the corner. So look at the two notations. You remember parallel has two, looks like two parallel lines, and then the upside down T for perpendicular. So let's take a look at a sketchpad demo to help us remember the relationship between parallel and perpendicular slopes. Alright, so in this demo on Sketchpad, I've got it set up so I have a line here, line AB, and I've got a point that is not on the line. So you may recall from geometry, the parallel postulate says that there's exactly one line through point C that's parallel to AB. So let's go ahead and draw that thing in there. And notice on Sketchpad that if I just move one of my lines, the other one moves with it to stay parallel. Okay? And then I've got the slope of my line. That's the blue line, that's AB right there. Its slope is measured. And if I measure the slope of line that's going through C, the parallel one, I can see that the slope numbers are exactly the same. So if I have parallel lines, then their slopes have to be equal to each other. Equal slopes. Easy to remember. Parallel lines, equal slopes. Okay, so now let's look at the perpendicular side of it. So similarly in geometry, if you have yourself a line or point that's not it, there's only one perpendicular line that can go through that point C. So let's draw that sucker in there. Of course, this makes a right angle, and notice no matter where I move this, it stays perfectly perpendicular to each other. So let's look at the slopes. If I look at these two slopes, there's not a lot that I can just tell from looking at it what the relationship is, other than I've got myself a positive one and I've got a negative one. Alright, so let me move it someplace else. Yeah, so a positive and a negative. It just switched which one was which. So it's too difficult to just look at these decimal numbers and tell what's going on. So how about we look at the product of these two? Let's multiply these two together. When I multiply them together, well, look at that. I get a product of -1. I should expect the negative sign because one's positive and one's negative. When I multiply, I get a negative number. But in order to get 1 as an answer when you multiply, this means that the two numbers have to be reciprocals of each other. For example, if one is 1/2, the other one is 2/1. If one of them is 5/4, the other one is 4/5, because whenever you multiply reciprocals together, you get 1 as the answer. Okay, now one other special case. If one is horizontal and one is vertical, see if I can get it exactly on the money. Okay, so this one's making some kind of a mistake because it's saying the slope of one is 0, the other one is -374, but we know that the slope of the other one should be, there it is, undefined. Okay, so there's the special case. If one's horizontal, the other one's vertical, slope is 0, the other one has to be undefined in order to be perpendicular to each other. Otherwise, they are, let me move this someplace else, negative reciprocals of each other. They are opposites, and you take one and you flip it, take the reciprocal, and I get the slopes of my perpendicular lines. Oh, all right. Okay, so we saw that when our two lines are parallel to each other, they have the same slope. So you can see over here it is a biconditional statement, an if and only if statement. Two lines are parallel if and only if they have the same slope. All right, so if the slope of one line is 1/3 and the slope I have another line that's parallel to it, it's also going to be 1/3. Okay. On the other side, two lines are perpendicular lines if and only if their slopes are negative reciprocals of each other. Negative reciprocals. So, for example, if the slope, there we go, if the slope of one is, let's say, 2/3, then the slope of anything that is perpendicular to it is going to be a -3/2. Let's flip it and change the sign. Negative reciprocal. As a matter of fact, I'm going to come up with, well, we have come up with a verb to do that. To take the negative reciprocal, we're going to call it reciprocate. To reciprocate is a verb that means to take the negative reciprocal. So if I give you the slope and I want the perpendicular slope, you flip it and change the sign. That's called reciprocating. Okay, so sometimes that statement is made like this. Look at this right here. That the product of the two slopes is equal to -1. Well, the reason why is if you first multiply two reciprocals together, you get 1, and then if one's positive and one's negative, you get -1. Okay. So on exercise 6, tell whether the parallel lines are parallel, perpendicular, or neither. If they are parallel, their slopes are going to be the same. If they are perpendicular, they will be negative reciprocals of each other, and they're neither if they're not the same and they're not negative reciprocals. So I want you to pause the video and find the slopes of lines 1 and 2 and see if they're parallel, perpendicular, or neither. Alright, so these are the answers you should have gotten. So on number 1, line 1 had a slope of -3 and line 2 had a slope of -3 also. They're the same, therefore the lines are parallel. On the second exercise, line 1 has a slope of -3/2, and the slope of the second line has a slope of 2/3 whenever you reduce the fraction. Those are negative reciprocals of each other, therefore the lines must be perpendicular. Okay, one more question here in this objective. Number 1, if two distinct lines are parallel, what do you know about their y-intercepts? So let me just sketch a little picture here. Here's my graph. Here's one line, and let's say here's another line that is parallel to it. If these are two different lines, what has to be true about their y-intercepts? Well, what has to be true about them is that they have to be different. They couldn't be the same, because if they were the same, they had the same slope and the same y-intercept, they would be the same line. So they have to be different. Alright, number 2, if one of two parallel lines has a slope of 1/a and a is less than 0, is the slope of the other line positive or negative? Okay, so first of all, if the slope of 1 is 1/a, then the slope of the perpendicular one is, I flip it and I change the sign, -a, right? -a/1. And of course I'd look at that negative sign and I'd go, oh, I think the other slope is negative. However, this is saying that a is less than 0, which means that the slope originally for this line is negative, and the negative of a negative is a positive. So the slope of the other line must be positive. Tricky.